This song always gets me excited. Nice to meet you, everyone. I am Yoav Yanovski, and I'm a senior technical manager at Vonage from the Tel Aviv branch. And I'm here to talk to you guys about micro frontends. Good time to clap. So before we'll actually start talking about micro frontends, I want us to try and understand why are they even relevant. And in order to do so, I want to tell you just a tiny bit about Vonage. So Vonage is a US-based corporation that focuses on cloud-based communication solutions. Now we have a lot of product, but we really have two awesome ones, and the only reason I'm saying they're the awesome ones because I'm part of the development team. One of them is called VBC, that's Vonage Business Cloud, a Vue.js application that offers a unified communication solution for our customers. So our customers can basically use VBC to have phone calls, send SMSs, voicemails, video meetings, and so on, basically everything in a unified solution. Is that clear? No? Let me show you a video then. Oh, I didn't connect the audio. It's an important part for the video. Thank you.
Vonage's Unified Communications unifies all your business's boring communications into one exciting platform. Unify, 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 not unified, unified.
So I think we all get what unified means now, right? And on the other hand, we have Nexmo. Nexmo is Vonage's API platform, which basically enables developers such as yourself to utilize Vonage's communication capabilities to your own product. So does anyone doesn't know what APIs are? There's a guy there with a face whose hands is up, so.
API. Alligator Party Island. All Pineapple Igloo. Animated Penguin Ice Cream. Good APIs, but Vonage's APIs help developers build communications into their apps, which is cooler than those. Except for maybe the igloo.
So, on one hand, we have a very large developer community who's using Nexmo. Over 500,000 developers are using Nexmo on a daily basis. And on the other hand, we have over 100,000 businesses who are using VBC. We basically started thinking, and we're saying, why shouldn't we utilize the great Nexmo developer community that we have to enrich the VBC user experience? And then the App Center came into birth. We have created an App Center that enables third-party developers to integrate their applications into VBC so that our customers can use it. And once we announced it, we got a lot of traction. We got a lot of companies that started lining up, and they wanted to add their product into VBC. So we started thinking, and we were saying, what does an application need? Any ideas? Any ideas? What do you think an application would need? Software. Who says software? Well, no, APIs. One thing that application would need is to have APIs. We need to have the ability to access Vonage's information, to get information about our users, and even in some cases to perform actions on their behalf. Any other examples? No one's speaking. So. Okay, so money. No developer in his right mind would ever build an application for Vonage if he's not going to get paid for it. We're not suckers. So we need to find a way for us to actually pay the developers who are building applications for VBC. And last, we need to find a way to get their user interface into our user interface. So naturally, I'm going to focus on the most important part here, which is making money. I'm kidding, of course, we're in a Vue.js conference, so I'm going to talk about how we're going to get applications to embed their custom user interface into our application. And the way we used to do this in the bad old days was basically getting developers from the third-party team, getting developers from my team. We started working together, we built a prototype, we did some development, we tested everything there was a test lecture, so we tested everything, and eventually we launched the product. And that worked. It was fine, but honestly, it wasn't the best. It was very hard to keep working this way. It was very slow. All the other teams that came in, they actually had to write code over our repositories. It was extremely hard to maintain. And although we are literally the best developers in the world, kidding, of course, we have bugs as any other developer. So whenever we got a new applications, we also affected our existing features, which was a shame. And eventually, we ended up with a very huge monolith website. So we started thinking, is there something better that we can be doing? And you know where we looked? To the back end. And the guys in the back end, they have a thing that's called microservices. I assume all of you are familiar with microservices, but for those of you who are not, microservices is basically a service architecture that says we have a system built out of autonomous, individual, independently deployed microservices components. Each one of them has their own responsibility, their own capabilities, and they together create our unified server architecture. And sounds like this can work for the front-end side, right, guys? Well, no. We have so many challenges in the front end which we simply don't face in the back end, and let's be honest here, vice versa as well. So the challenge that we're facing is, first of all, we have to provide a unified user experience. So if we're going to think about the back end guys, they can have a multiple system, having one component which works and has a REST API, another one that provides a SOAP API. We can have one component that responds in JSONs, while another for some reason responds in XMLs, and that can work. That can work for the server side. But when we're getting a system together for the front end, we can't have one component that's going to look as though it's like a blue sky component and another component that we'll integrate, which is bright pink. It will just look weird, and we're going to provide a bad user experience. We can't have one component that supports right-click while another one doesn't. We have to maintain and provide a unified user experience. Also, for the guys in the back end, they can have services that weigh 200 meg, 60 meg. They can even have databases that weigh 2 tera, and that's simply fine. For us, it's not. We always have to make sure that the application we provide our users, even if it's composed out of multiple small applications, it's going to have, bless you, it's going to have the smallest bundle size there is. We have to take into account the fact that our customers and our users may be having network latencies that we had, like we did yesterday, who didn't take into account. So we need to actually provide a best and smallest bundle size. Next, on the server world, each one of the microservices components is usually on its own server, whether you're using EC2 or it has its own container if they're using Dockers. And basically, if it crashes its servers. And that's fine. The rest of the system might work. Some features may not work, but the system in general will work because each one of those services is autonomous. When we're talking about front-end, each one of our components is going to run on the user's browser. So if one of them may crash, if one of them has a bug, it may affect our entire application. And going back to user experience, our user will get a very bad user experience. And last is going to sound like me bitching here, but we were saying, awesome, that approach can work. Let's go out. Let's find an open source that can solve us this problem. And there isn't any standard library for micro frontends. So those are our challenges, but as the Israeli Wonder Woman says, we can do it. So let's talk about what micro frontends are. My favorite definition of defining micro frontends are basically independent, self-deployed components that together compose our greater whole application, or our parent application. As you can see, each one of those components has its own build cycle, its own test pipeline, and it's being deployed independently, and together we get all of them to compose one big application. And honestly, I think this is awesome. First of all, it's very easy to maintain. We can have multiple repositories. Each one has its own roles. We can have tech freedom. The fact of the matter is, if we have a parent application which is built in Vue.js, doesn't mean that developers can build their applications using Angular or React or any other framework that they want because they have tech freedom to just embed their frameworks into ours. Independent deployment. No longer will developers have to rely on the parent application deployments. Whenever they're ready, they're good to go. Whether they're working in sprints, they deliver a version every 2 weeks, or they're doing CI/CD and they deliver with every feature, they can deliver whenever they want and they're good. And it's customizable. If you remember, our example is the fact that we need to create an app center. So this means every one of our users should get a different user interface. And using micro frontends, we can actually create a composable and customizable website. So this is VBC. Now let's strip this apart for a second. And what we're seeing here is the fact that we have micro frontend components that are composing VBC. And the way we do this is using what we call the micro frontend orchestrator. It's a pure JavaScript file, exposes a simple interface, and one of the key functions in that interface is inject application. So it's get an injection configuration, where do we want to inject, and inject a micro front-end component. On top of that, it also enables the micro front-end components to communicate with the parent application and with each other. So we also have the UI injector, which injects them, and a communication layer. And last, we have the micro front-end components who are communicating with the parent application and with each other. So what's the best way to inject a micro front-end component? Well, honestly, there are multiple methods. Each one has its own use cases. I like to differentiate them to two categories. One, single framework methods, and another, multiple. Single framework methods basically means that if I'm going to choose a single framework method, I am sort of limited to one framework. So if I'm going to go for single, and let's say my parent application is a Vue.js application, each one of the micro front-end components that we're going to inject is also going to be a Vue.js. So it also has some advantages, because if my company knows how to work with Vue.js, it might be simpler. It's going to be easier to share components. So this way is one of the ways that you can just do using single framework. Another one is multiple framework. Multiple framework is just the opposite. This saying that you can have a parent application, which, as I said, is a Vue.js, and you can embed, if you're crazy, an Angular component. That's fine. So let's talk a bit about a few of the methods that I showed up here. I'm going to talk about one that is a build time integration. And honestly, I think we all are familiar with this method, and it's very easy to implement. It's simply using something like NPM. I can go into my website and can see a nice component. It's autonomous, and I want to use. I'm simply installing it on NPM. And if I'm even using tools, advanced tools like Lerna, I can manage versions. I can have shared dependencies. And that way to go is used by a lot of top brands, and it's very easy to test. One of the problems there is that it requires rebuild. The parent application has to rebuild, update the versions of each one of the components we use if you want to make changes, and it's not customizable. On the other hand, we have the runtime integration methods. So one of the newish ways to integrate a micro front component is using web components. For those of you who are not familiar, web components are web platform APIs that enables us to create reusable, customizable, encapsulated HTML tags that can be embedded in almost any website. And honestly, almost every framework, including Vue, supports bundling our website or our components into web components. Web components are also injected using Shadow DOM. Shadow DOM is basically another part of our document DOM that provides some isolation. So if we have some scripts and some styles that are going to be done in our web component, they should not affect our parent application. It doesn't work 100% of the cases, but it's a good way to have some basic isolation. The one problem that we had with web components, and although we do think they're the future for micro frontends, we felt like they're not quite there yet. Whenever we were hitting advanced use cases, there weren't many documentation, you couldn't see a lot of brands who were doing it, so we felt like it's the future in a bit. Another way to go is the good old iframes. Iframes, as you all know, are basically running another website inside our website. And by doing so, you get 100% full isolation. If you have any bug within your JavaScript in the web component that has been injected, it will never affect your parent application. It will just work. Also, it's widely supported. Almost any company that wants to enable you to inject some of their website into you will do that using iframes, like the YouTube example I have up there. And of course, it's used by top brand. The bad thing here is that it's kind of old-fashioned, and it doesn't enable us to share dependencies. So if I have a parent application that uses Lodash, and one of my microfront components uses Lodash, basically means that both of us are going to download Lodash. Another way to go is using JavaScript injection. JavaScript injection is a nice, awesome way to go, which is pretty simple to understand. During runtime, we're actually downloading a JavaScript file. That JavaScript file exposes a render method. That render method gets a selector as to where it should render the component, and it creates a component where you told it to. Now, the awesome thing here, it's very flexible. You can basically do everywhere. It's very simple to transfer data from the parent application to the microfront application and vice versa. And it's very simple to convert our existing applications to become a JavaScript injected applications. The bad thing is no isolation. If we have injected a microfront component using JavaScript injection, and they have a bug, or they're a malicious website for any reason, they have the ability to get all information about the user and crash our system. So I assume you guys are wondering what we use in Vonage. I know you are, right? What do you think we're using? Who said iframe? Well, no. All of the above. We thought, okay, there isn't just one method that we can just use, and this will be the one that works for us. So what we did is that we enabled the MFO, the micro-frontend orchestrator I mentioned before, to get configuration. That configuration holds how am I going to inject, where am I going to inject, properties I need from me in order to inject an application, and we just do it. So yes, some cases we might inject using iframes. In other cases, we may inject using web components or JavaScript injection. But we thought there isn't just one perfect method that's just going to work. Also, we discussed unified user experience. If you remember, I said that we can have a microfront component in bright pink, and while our main application is in sky blue. So we need to find a way to make our component look and feel as though they are a Vonage component. So in order to do that, honestly, it was quite simple. What we did was we created a shared CSS library, and we just gave it out to all the developers who are building components for us. And that was awesome. So their website started looking like a Vonage website. But it wasn't enough, and we decided we also want to make it feel, so have some logic as though it's a Vonage website, and we simply create a shared component library. So we enable developers to get components from us, like a Vonage button, a Vonage table, which looks and feels as though it's a Vonage application to write their user interface that they're going to inject to VBC. So we also mentioned communications. So what do you think apps even talk about? They don't gossip, they talk about something, right? Any ideas? Any idea is a good idea. So one thing that apps talk about are lifecycle events. Every one of the applications that is going to be injected into our parent application has to report lifecycle events. We have some events that are being reported from the parent application by the MFO. For instance, before I'm going to mount an application, that's the event the MFO is going to fire. And then once an application has been downloaded and its code is start running, it reports initialized. Everything is being sent back to the parent application. Once it's good, it did all its API access. It's got all the data it needs, and it's ready to be presented. It reports ready, and that's when we'll actually present the application. And then the MFO reports mount. Before we're going to terminate the application, we report terminate application to the application, and eventually the application has been terminated. Another thing that applications may want to talk about is transferring data. Very simple, very generic. We can have a email sending application which will need data from context application. So we provide them through the communication layer the ability to transfer data between each other. Applications can also want to execute actions. They can want to say, okay, I'm a context application and I want to call someone. Now, a calling application is a different one. So I'm just going to trigger an action, say, I want to call this number. The MFO is going to manage permissions, what is the application allowed to do, and everything else, and then the action is going to be activated. And the way we did the communication part is using what we call MFC, Microfront Component SDK. So we wanted to make the lives of our developers as simple as possible. So what we're providing them is just an SDK. They can install it using NPM, and that SDK basically wraps all the communication for them. They don't have to think about how they were injected, whether it was iframe, web components, or JavaScript, whether they need to communicate using post events, post messages, and meeting events, or using callbacks. The MFC SDK does that for them. And we provide a variety of methods and a code example through which our developers who are building apps for us, can just utilize this capability, and they don't have to worry about how they're going to be injected. By the way, we're also building an MFO version for mobile, and we're also providing this SDK that can be deployed for mobile applications. This is on our 2020 map. Cool. So seems like awesome, right? That seems like we can basically do anything now, right?
People think unified communications are boring, but with Vonage you can chat with Deborah, conference call, share a doc, call the boss. Yeah, basically all that in one platform.
So, do you guys, who wants to see a demo? With a raise of hands, please. Everyone who doesn't raise their hands is not going to see a demo, so raise your hands. And hold them up for a second. Cool, cool. Now let's make it vocal. So, do you want to see a demo? Yes, yes. But I think again, if you don't, just leave the room right now. So I'm going to try again. Who wants to see a demo? Sorry, do you want to see a demo? Yeah. Nice, thank you, thank you. That goes right on my Instagram. So I didn't make a demo. I don't have a demo for you guys. Would you settle for a live production example? Does that work? Yes, cool. Okay, so this is VBC. What we're seeing here is system already running. Honestly, this is not production. This is one of the versions that's been done by one of my developers, I'll be honest here, but the MFO, the microphone injection is already up and running in production. And once you can see right here, on this part over here, that we have applications. Applications, all of them have been dynamically injected using web components, using a microphone orchestrator, and we can now use them, and none of them are part of the VBC code. We can also inject parts of the microphone components in different parts of the application. For instance, you can see here, Isaac Juma, one person that I called to, and I can click Salesforce. This is a Salesforce application. None of the code that's going to be, none of the components that are generated here, none of this code base that's built, this lovely user interface, is in my code base. The guys who've created the Salesforce application build it, and though it looks and feels 100% as though it's another VBC component. I'm going to go down to call recordings, for instance. This is an application that was built that enables us, if I'm having a call, it just records the call. And then we can go ahead and view the recording. So if I'm going to click on that application, you're going to see a loading screen. This is where we're actually downloading the URL for the application. The application gets initialized, and when it's ready, when it's finished accessing all its API, the recording APIs, and it's good to actually be presented, it reports through the communication layer a ready event, and this is when we're presenting it. If it's not going to work, that's internet issues, not our code. But it should have already appeared. So, anyone has some dad jokes for me? No? Oh, we're good. So we can see this is the application. Again, it looks and feels as though it is another VBC component, another VBC application. If I'm going to go to another screen, like I'm going to go back to call screen, and then I'm going to go back to the application, the MFO knows how to keep that application persistent so they won't have to reload again. And I'm getting all the features that the application have. I can like click here.
Frontend is amazing.
Frontend is amazing. That's what the recording just said. Cool. So going back to the presentation, let's talk about what next. So what are the next things we need to do? So first of all, if you have any questions and if you want to learn more about microphones, what my team did, we're all here. They didn't know that their picture is going to show up, but they're sitting right there in the middle row. So you can grab each one of us if you want to learn some more. Give them a round of applause. They built it. I'm just the manager. So come up to us at the break time, and we'll be more than happy to elaborate more about what we did. Next, keep in touch. If you have any questions, if you want to contribute, this is our email, this is our team's email, this is my personal email and my LinkedIn page. Twitter is not that big in Israel, so I have a Twitter account, but you send me an email or a LinkedIn request. And another thing that we're doing, we've decided, even though we are a huge American corporation, we're going to give back to the community, and we're actually releasing the microphone orchestrator and the MFC SDK as open sources. We're going to release those packages. They're already live on NVM. We're going to make their Git repo open source too by next week. So anyone who wants to see, we're more than happy to get your comments. You're more than happy to review code if you want to add features there. But everything has been done and made for open source. Feel free to clap now. That's it. Thank you very much for your time. I had a great time presenting. And again, we're here if you have any questions.